In this video, we are going to graph the following polynomial. F of x is equal to x minus 1 quantity cubed times x plus 3 squared. To do that, we're going to follow these steps. Steps 1, we're going to find the intercepts, both x and y. Step 2, we're going to look for any symmetry, even or odd. Step 3, we'll look for the multiplicities of zeros, which will tell us how it's going to behave near the x-axis or when it hits those zeros. 4, we're going to look at end behavior. Step 5, we'll sketch. We'll add any extra points at that point if necessary. And number 6, we'll check the number of turning points. So let's start with step 1, the intercepts. And let's first start with finding that y-intercept. Y-intercept means it's on the y-axis, which means your x is 0. So plug in x is equal to 0. And I get a 0 minus 1, so negative 1 cubed times a 0 plus 3, which is 3 squared. 3 squared is 9, negative 1 cubed is negative 1, so this is a negative 9. So 0, negative 9 is my y-intercept. X-intercepts, you're on the x-axis, which means your y value or your output is 0. So I'm looking at 0 is equal to x minus 1 cubed times x plus 3 squared. So I have a product of two things are equal to 0. So that either means x minus 1 cubed is equal to 0 or x plus 3 squared is equal to 0. Looking at x minus 1 cubed, take a cube root of both sides. Left-hand side, you're left with just x minus 1. Right-hand side, left with 0. Add 1 to both sides, you get x is equal to 1. Take a square root of both sides on this one. You get x plus 3 is equal to 0. And then subtract 3 over, you get x is equal to negative 3. So my two x-intercepts that I have are 1, 0 and negative 3, 0. So that's step 1. Step 2, let's look for symmetry. And that's going to involve plugging in f of negative x. If you get back f of x, that again means it's even, which is symmetric about the y-axis. If you get back instead f of negative x is equal to negative f of x, that's an odd function, and it means it's rotationally symmetric or symmetric about the origin. And if you get neither, that's perfectly fine. It just means you don't have that symmetry. So let's plug negative x into our function. That's going to look like a negative x minus 1 cubed times a negative x plus 3 squared. And you can see, since now that I have these negative x's instead of positive x's there, this is not the same as f of x. What that tells me is this is not even. So this polynomial graph will not be symmetric about the y-axis. You can also see that there's essentially not any negative 1 times the whole function. And to see that a little better, if you pull, say, a negative 1 out of this first term, I'll have a negative 1 cubed times a positive x plus 1 times a negative x plus 3 squared, which looks like that negative, oh, I forgot my cube up here, didn't I? Cube. A negative 1 times x plus 1 cubed times a negative x plus 3 squared. So here's that negative from right here, which means the other part has to be f of x. Well, this is not f of x. What this means is this is not equal to negative f of x, which means it is not odd. So I'm not going to have any rotational symmetry either. So that's step 2. Step 3, let's look at the multiplicities of our zeros. My two zeros, which I found back up here as x-intercepts, means my zeros are x is equal to 1. And my other zero is x is equal to negative 3. Well, x is equal to 1 came from, if you look back at the function, it came from here. In fully factored form, I have essentially 3 factors of x minus 1. That tells me the multiplicity of 1 is 3. If you look at x plus 3 squared, negative 3 is the 0 from that, and I have 2 factors of x plus 3. That tells me the multiplicity of negative 3 is 2. So the multiplicity of x equals 1 is 3, and the multiplicity of x equals negative 3 is 2. So odd multiplicities mean you're going to cross the x-axis. And even multiplicities mean you are going to turn around at the x-axis. And the neat thing about how they're going to cross or how they're going to turn around is essentially x raised to this power. So this is going to cross like essentially a cubic or an x to the third. This is going to turn around essentially like a quadratic or an x squared. That was step 3. Step 4. Let's look at the leading term. So our f of x again, just so we don't have to scroll all the way back up, was x minus 1 cubed times x plus 3 squared. So if you actually expand this all out, you get an x times an x times an x. Well, that's x cubed. If you expanded all this out, you get an x times an x. Some other terms too, but essentially that x squared. So x cubed times x squared is x to the 5th. This is my leading term. It's an odd degree polynomial, positive coefficient, so its end behavior is going to be essentially a down up. All right, step 5. Let's start graphing this function. We'll add any other points that we think are going to be necessary. So my y-intercept was 0, -9. It's like down here. My x-intercepts were 1, 0. It's about there. And -3, 0. I'll put it about there. And behavior was a down and then an up. And now I can add in these thoughts of multiplicity. So -3, which is my 0 right here, had a multiplicity of 2. What that means is as I come into this thing, I'm going to turn around first of all, and I'm going to turn around like a quadratic. Okay? And then I have to go through this point, which means somewhere in here I have a turning point, and I'm not quite sure where it's going to happen. So let me plot one more point in here to see what it's doing. And I'll grab -1 for real no good reason other than it's between 0 and -3. And I wanted to talk about -1. So if you plug that into the function, you get a -1 minus 1 cubed times a -1 plus 3 squared. So I get a -2 cubed times a 2 squared. -2 cubed is a -8. 2 squared is 4. So this is going to be -32, which means -1, -32 is a point on that graph. So it goes way down here. And then it's going to turn around somewhere in the middle. So something like this. Got to go through there. And then I have to go through this point, 1, 0, which is my other 0. It is an odd multiplicity of multiplicity 3, which means it's going to cross. And it's going to cross kind of like that cubic does right at the origin. And then it heads up here now. So this is my graph of y equals f of x. And the last thing is just to check to make sure that I have an appropriate number of turning points. Looks like I have 1 turning point here, 2 turning points there. This isn't turning, it's just kind of leveling off, barely. So it's not a turning point. So 1, 2 turning points is what I have. This was a degree 5 polynomial. And so at most it could have 4 turning points, and 2 is less than 4. So we're okay.